All right, for example 2, we got some real world problems. So it says Jaylene was responsible for raising the flag outside her workplace each morning. If the height of the flagpole was 24 feet and the distance from Jaylene to the top of the flagpole was 36, find the angle of elevation. So we got Jaylene over here, and then we got a flagpole here. The flagpole was 24 feet in height, and then her distance to the flagpole was 36. And we want to find the angle of elevation, and that angle of elevation or depression is going to be that horizontal angle to the 90 degrees. So like this is like our theta or our x. So for this one, what we're going to do, and actually this is going to be a tangent one, but that's okay. We know how to use tangent. So for this one, we're going to do opposite over our adjacent over here. Oh wait, no. It's not. It says Jaylene to the top of the flagpole. See, I can't even read. That's my mistake. I was like, why are we doing a tangent here for this one? So to the top of the flagpole was 36. So that means we have 36 over here, and this is our hypotenuse. So SOHCAHTOA. So opposite hypotenuse goes with sine. So I'm going to have sine of my angle, which right now is theta, equals my opposite over my hypotenuse. And again, I want to get that theta by itself, so I'm going to do sine inverse over here. So we're left with theta equals sine inverse of 24 over 36. And then we grab our scientific calculator. So sine inverse of 24 over 36, and we get 41.8. So our angle is 41.8 degrees. For part B, a ladder is resting against the outside of a building. So we got a ladder over here. Again, that ladder is always our hypotenuse is always slanted to climb up it. The ladder is extended 23 feet and reaches a distance of 17 feet up the wall. What is the angle of elevation formed where the base of the ladder rests on the ground? So that's exactly what we have here. So again, if this is our angle, we have an opposite and we have our hypotenuse. So again, O and H go with sine. So you have sine of my angle theta equals my opposite over my hypotenuse. We can take our sine inverse. So sine inverse over here. So we get theta equals sine inverse of 17 over 23. And then we get punch that into our calculator. 17 over 23, and we get 47.7 degrees. For part C, a tree casts a shadow. So we got a tree and then a shadow on the ground. The tree is 40 feet tall, and the distance from the top of the tree to the top of the shadow is 47 feet. What is the angle formed from the top of the tree? So now we're over here. So for this one, we got our adjacent, that's right next to the angle, and our hypotenuse. So again, if we're thinking about SOHCAHTOA, if I got A and H, I'm going with C for cosine. So cosine of my angle equals 40 over 47. I'm going to do my cos inverse. Cos inverse over here. And then I'm left with my theta equals cos inverse of 40 over 47. So let's see what that is. So cos inverse of 40 over 47, so 31.7. So our theta equals 31.7 degrees. And then for part D, a ladder is resting. So we still have a ladder. Ladder is resting on the outside wall of the building. The ladder is 20 feet, and the base of the ladder is 5 feet from the ground. So base of the ladder I think it should say wall. I think that's a typo. It's 5 feet from the wall. I will fix that. There we go. What is the approximate angle formed between the ground and the ladder? There you go, like that. Okay, so for this one, we got this. So we got our opposite and no, we don't got an opposite. We have nothing on the opposite, but we got our adjacent and we got our hypotenuse. So again, adjacent hypotenuse goes with cosine. And 5 over 20, A over H. We're going to do cos inverse to get rid of that cos. And then we're left with theta equals our cos inverse of 5 over 20, which is going to give us, let's see. So cos inverse of 520 is 75.5. And that would be our angle.